All right, so while this thing loads up, here's the idea. And this is a really silly couple examples. If I went out and I observed, I can't remember if I said this earlier this semester or not, but I go and watch some basketball games, right? And this is actually a part of my life. Because I met my father when I was 15, because he left when I was really young. And I was already like an inch taller than him, so I had these basketball dreams that were dashed. I'm like, not my genes. So I got a great fadeaway shot, but I don't have anything else, because I'm a little bit high challenge. But if I went and observed basketball games, I'm like some alien, and for some reason we got tired of probing cattle, so we decided to watch some basketball. I might think, holy crap, when these humans play basketball, they get taller. That's interesting, right? So, obviously that is wrong. You don't get taller because you play basketball. What's the correct relationship there? Somebody has a higher chance of playing basketball if they are taller. Exactly, right? Now, that doesn't mean they're going to play basketball if they're tall, period, right? But it's just about probabilities or relationships. Okay, all right, I like it. So this, I start with a similarly silly example. And this is by no means a possible experiment to conduct, just to say that right off the bat. I'm not requesting that you try this out, just in case my dean watches this and wonders. So here's the idea. Here's an example just to get us into this. If I had a 7 a.m. class, when I first taught here, I had a 7:25 a.m. class. Because that was what was left for me, right? So that was horrific. But let's say I have a 7 a.m. class and I have a big test the following day. And that night, I go out and I have a few beers, right? So depending on who I am, I might have a worse time the next morning. What do I mean by that? So here's the number of beers that I drank the night before versus the grade that I make on the test the next morning. So what's the trend in both of these? There it's a little bit harder to see because of the outliers, but here you can really see, the trend, right? So as I drink more beers, it seems that the grade I would make goes lower. I like it. Now that doesn't mean, so to be really careful, like I just said with the basketball example, in any study you do like this, you have no idea what is causing the other thing. There could even be a third variable you're not looking at that's affecting both of them. And in fact, there's quite a few other variables that would affect this situation. I would hope, right? It has nothing. It's just not just dependent on how much beer you drank. I drank 0, I got 100. I don't know what the hell I'm doing. No, that doesn't make any sense. So there are obviously other variables such as sleep, studying, doing homework, all this other shit. So which one is more realistic? What? This one's more realistic, right? Which one is a stronger relationship? This guy. So it's a much stronger relationship. Very quickly, why would you say this is a strong linear relationship?
Because points are all closer together and they all follow the same.
Yeah, you can imagine a line. In fact, I could try to draw a line. Let's see what this is. It's a pen. Okay, good. You can try to draw like a line that would sort of, whoa, crap. Okay, it's a little wavy underneath. That sort of averages out. I could try it over here too. This is going to be much worse, but a line that sort of averages where the points are. So this is like a 2D average in a way, that little line I just drew. It's the line of best fit, which is a beautiful name because it's the line that best fits all the points. This is a stronger relationship because all the points are tighter, closer to the line. With me? So there, do you guys agree with me that's roughly where a line would go to demonstrate the trend? But the points are obviously much further away. Who is this person? How much did they drink? Not a lot, but they didn't make a good grade. Well, they probably didn't know anything anyway. It didn't matter how much beer they drank. It might have been better if they drank more. And who's that person there? Drank a lot, but they still... Yeah, so they can hold their liquor and they knew what they were doing, right? Or statistics requires you to be drunk to do it. Now again, that's nothing, don't test that. It's probably not correct. My buddy used to get better at pool the drunker he got. It's like this not fair stuff. Okay. So again, this is a similar situation, except this one, what's the difference between the first situation and this situation? The biggest difference?
It's a different positive thing.
Yeah, so the top one has a kind of a negative trend, and this one's got a positive. Now, obviously, I would hope this is positive. The number of hours you study would have a positive effect on the grade you make. But again, which one's more realistic? This one's going to be more realistic. You got this person that studied a lot, didn't make a very good grade. Either they don't know how to study or it just ain't sinking in. This person barely cracked their book, but they're making a really good grade, right? And they only sit right next to you and you're like, ugh. Alright, but if you take those outliers, even with them in there, you can see that the line would be about right here, right? That would be the graphical average. So what's interesting is, I can draw that line pretty decently just by eyeing it. You know, if I draw one and draw another one, I can get it pretty well drawn. And what do I try to do when I draw that line? I'm trying to do what? What makes the line better or worse? Like obviously I wouldn't draw it here. It's got the right direction, but what's wrong with it? If I drew it right here? Well, I think it's probably the right slope. Do you see that? It's got the right slope. It's just not up high enough. The y-intercept is wrong, right? It should be higher. It should just be picked up. See here. So I want kind of the points to be about the same amount on each side, or to be honest, what I really want to have happen is to have the distance from each point to the line to be minimized. So sometimes we call it the best fit line. That's awesome. That's not just what I call it, it's just what everybody calls it. But it's also called the least squares line. If you square the distances, it's the line that has the smallest sum of those. I want it to be the closest it can be to all the points at once. Let me stop there for a second. If you think about it, that's what the mean does for a list of data. It is the number that is the closest to every point at once. So this is just a 2D analog to that, a two-dimensional analog. Okay, maybe. Okay. What's a couple of cool things? Obviously, this is the stronger relationship, and this is the more realistic one. If it was perfect correlation, perfect positive correlation, what do you think that would mean? What do you think that would look like? If it was perfect. Why is this not perfect? Why is that not perfect?
Because not all dots are like in order, I guess. Like they're not one in front of the other. They're all kind of still over.
Yeah, the minute a point is not on that best fit line, it's not perfect. So, like a perfect negative would be they line up all on a line. They line up perfectly. A perfect positive, of course, would be the other way around. They all line up perfectly on a line. Now, in real life, how often does it happen? Not. How many of you guys, anybody have kids? Anybody have kids? Do you know the height and weight chart? Do you know what I mean when I say that? The height and weight, the percentage, the 90 percentile for height and whatever. All right, if you guys know what I'm talking about. So, something like that, you're never going to have perfect relation. That's why they have these, in fact, it's a beautiful example of statistics. You have the middle line, and then you have above and below it, kind of like a standard deviation. And then there's acceptable, a minimum usual value and a maximum usual value, right? So you could be too far out for weight, and they say pull it back a bit there. Or if it's the height thing, there's not much you can do about that. You guys kind of with me here? Okay, maybe a little bit. Okay, so, thank the gods, I'm not going to be making you do too much by hand. You are going to have to graph a few scatter plots on your own, but I hope to God you could graph X, Y points. That's really all this is, right? So if I said somebody studied 20 hours and they made a 90 on the test, so 20, 90, bam, what's to be about that point right there, right? So that's how you create this scatter plot. It's what it's called, a scatter plot. You just plot a bunch of points. Cool, I like it. So the beautiful thing is we're going to be doing, this is the one section that I believe should be done mostly in the calculator. This is hard to believe, I understand, because you got me. So let me just finish out a couple things here. Since we got the mean is the line that we draw, what else do I want to know whenever I have a set of data? I want to know the mean. Whenever I have a set of data, I want to know the mean and the standard deviation. So here, standard deviation is not normal. It's not what we consider. We use something called R to come into place for the standard deviation. R is going to be 1 or negative 1 if it's perfect. So if it's perfect negative correlation, it would be negative 1. Perfect positive correlation would be positive 1. So what would be no linear correlation, like it's just all over the place? 0. Okay, let that make complete sense. 0 means no correlation. 1 means perfect positive. Negative 1 means perfect negative. So a good estimate for this, that's pretty close. I'd say a good estimate would be 0.9, negative 0.9 in this case, right? So R about negative 0.9 or something. Do you guys get the feel for what I'm saying? If I pulled more points away from the line, it's going to go 0.8, negative 0.7, negative 0.6. Keep pulling them away. That first one's probably got a negative 0.3 or something. It's not 0. There's definitely a trend, but it's not a very strong trend. I like it. This is what I meant by give you a break. This is not hypothesis tests. This is something that actually makes complete, immediate sense. Now, the other side of it is the math of it, trying to quantify things, right? Trying to give a number to it that would represent the strength, and just instead of just going, it looks like it's strong. No, give me a number so I can measure to see how strong it is. Oh. Okay. So on the back of this, I've got a little excerpt from the calculator guide that's up on the internet, on the website. I did not bring any calculators, so too bad. Get close to somebody. We're going to do some examples. I don't even have my own calculator. Alright, so if you have a calculator, what do you think you're going to do with this information? Yeah. There's list 1, list 2. Do you think you want to sort this? Never. Because that's got to go with this. That's got to go with this. Do you understand? Every point is the relationship itself. If you sort it, everything's going to be correlated. Everything in the universe. Right? The amount of butter you bought 1 week versus the height of the tree in the backyard. Oh my God. I got to buy more butter. The tree's going to get tall. No, it's not good. Alright, so let me catch up to you guys. Alright, you all got your own copy of this. You don't need that up there. Oh crap. So many buttons. So go to Snap, Edit, clear this stuff out. Oops. So as soon as you got all that stuff in your calculator, and again, please your God, don't sort it. All right, hopefully all that made sense. Don't do that to yourself. Now hit stat. And I want to calculate something. Now what do you think? Go over to calculate. Let's just see if you can see which one makes the most sense. Because what is it I'm trying to calculate? No. I mean, that's good. If I was going to make you do the whole formula for R, you'd have to go to 2var stats. Because you do finally have two variable statistics. So you could go there and get both means and get both standard deviations, or just list it all out for you. Yeah, but number 4. And we call it regression. We call it linear regression because to regress means to come back to. So if I regress, a linear regression means that it regresses to the line. It always tries to regress to the mean. It always tries to come to the mean. So linear regression. And of course, what's this all about? Yeah, instead of A, we normally use. Yeah, but they're stats people. You want to be different, right? All right. So everybody's playing along. You're with me so far? So if we go to number 4, it defaults to list 1, list 2. So if you got it there, you just hit enter. And let's see what you guys... Has anybody got more than I did? Yes. Anybody have more stuff showing up? Anybody have at least that showing up? Has everybody got at least that showing up that's playing along? Who needs help? Anybody need help? Oh, that's right. You got a lot of it, right? Oh, yeah, that's right. Because it's actually old. Just tell it L1. So real quick, if you have this, oh yeah, good job, Jeff. That's right. If it says X list, Y list, if you have the newer RAM, I think this is the older RAM. Just tell it L1 for X's, L2 for Y's. That's exactly how you would plot them. And then just go down to calculate. There you go. That's different for me. Has anybody got the numbers I did? Yes? A few of you guys? So something might have gotten entered wrong. Yeah. All right. So trust me. One thing I want you to trust me for sure is I understand that entering a list of data, you can easily make little mistakes. On the quiz and the test, I will ask you to come up and show me your calculator. There's going to be several things I want you to show me, but I can catch something major. And if it's nothing major, I'm not going to worry that much about it. Do you understand what I'm saying? So I'm not going to take off 80 points because you put, instead of 6.7, you put 7.6 in the 30th data point spot. That's, oh my God, it's heinous. But try to get it all in there correctly. You got more stuff than us, right? That's not fair. All right. So let's try to get more stuff. So let's try to be like Brianna. If you have your own calculator, you're not going to have to do this again. I honestly don't know why they make us do this. Because it doesn't have any adverse effects to turn this on what we're about to turn on. You don't have to turn it on again. It's just going to stay on, right? And it's going to record your conversations. But I mean, no. That's already happening with who knows what else. So if you hit second 0, this is a catalog of every function the calculator is able to do. All right. Absolute value, yeah. Yeah, it can't help you with your abs. It can do an absolute value of something, though. I want to go to the D section. So you see how it's got the little A for alphabetical? So if I just hit the button that has a D on it, it's going to be this one right here. Right below the math button, the X to the -1 button, there's a little green D. Do you guys see that? So just hit that, you'll go to the D section of the list. You only have to do this once. If this is your calculator, thank God. Now just scroll down to diagnostic on. Diagnostic on. And then hit enter, enter. It's very anticlimactic. Diagnostic on. Enter, enter. It should say done. How we doing? You guys all right? All right. Stat, go back to stat, calc number 4 for the linear regression to get that line. Hit number 4, and then you should have all this stuff showing up. Okay, so this data was actually me trying to mimic that very first set of data for the beers versus grades. That line there, what's the slope of the line? Negative 2.5. Let's write that down. So yeah, y equals negative 2.5. Let's make it 5.4. X plus 89. 8.3 is good enough. Cool. Right? So that is the equation of the line that would best fit the data. So and I guess for this wouldn't be there. Negative, which makes sense. Now here's something kind of cool that this calculator can do. It can plot the points through its matrix. It's a graphing calculator. Freaking better be able to do that. So see how to make it do that. First off, go to y equals. Make sure, oh my god, mine is in a weird set. Wow. Does anybody else got weirdness like this? If you hit your mode button, everybody hit your mode button right there next to second. If you ever have weird shit in your calculator or the graph or whatever, make sure everything on the left side is highlighted. See how the funky funk right here is not enter? Is in something called parametric mode. Let's not worry about that. So now if I go to y equals, it'll be normal for me. Do you see that? So I'm going to clear this out for right now. Just clear it out. Get it all out of there. I'm going to make sure everybody's with me. So the y equals, hit that button and make sure it's all empty. In fact, go down to the bottom. There's almost always something hiding down here for somebody. You can put 10 functions in this thing. And you're all like, wow, that's great. Great space. Thanks, Jeff. Can't put my towels in there. No. Now, not surprisingly, I'm going to go, see where it says right above y equals? What's it say right above that? Step plot. All right, that's what I want to do. I want to plot statistics. So let's hit second, y equals. And again, you could pretty much, probably could have done all this on your own if you just follow the instructions. Let's all, everybody do this. Everybody hit number 4. Enter. Let's just all start with everything turned off. Alright. Everybody do that? So plot's off, done. Is that cool? Alright, let's go back to stat plot. Pick number 1. Plot number 1, hit enter. And now you're in here. Look at all this shit this thing can do that I never told. Ha ha ha. Sorry. You can make pops and whiskey. Make a histogram. Sorry. Oh, read your manual. But also, obviously, I don't want calculator doing your work for you, so but let's turn this bad boy on, enter. I want this highlighted right here. I want a scatter plot. So I want the very first thing highlighted. Is that cool? So make sure that one's highlighted. Make sure the X list is L1 and the Y list is L2. And then this is what the marker is going to be for all the data points. So I'm obviously a square. If you feel positive today, or if you feel like a speck of dust in the universe, you can pick whichever one you like. Now, this is the key thing. This is what people always forget and they get freaked out. If I hit graph right now, I'm either going to get like an empty thing. Let me know if you get an error.
Yeah.
Just hit graph. What kind of error you got?
Just error window range.
Freaky. Okay. Alright, so here's the thing. So it's just go to quit. See where it says quit? Cool. So that's not very good. I want to see a bunch of data points, right? That's what I want to see. So here's what you got to do. The calculator just goes to the window. It just goes, right now my window is set at 2. See how it's 1, 2, 1, 2, 1, 2, 1, 2? My window is set -2 to 2, -2 to 2. That's what I'm looking at. And of course, all these beers and grades, they're not in there. Right? Nobody made a 2 on the test, right? On this data. So what I do is, thank God the calculator can find it all for me. If you hit zoom, right there in the middle, zoom. Now if you scroll down, Let's see if you find out what's a smart zoom to use. Oops, go back up. Zoom which one? Zoom stack. So that'll zoom in on your statistics. Hit enter. Kabam. So let me know if you don't get that. Everybody got that okay? That wants to? Everybody wants to, obviously, right? Because you want to do well. Okay. Does that sort of look like? I try to make points that sort of made it look like this. That's a pretty good job, Jim. Right, this one I just made in like MS Paint more than likely. Just plopped points in places. Yes, I know. My skills are amazing. All right, so I need to see this, but I need to see more than this. I want to see the line of best fit too. So obviously, hopefully this is obvious. Where do I go to make the graph of the line of best fit? I'll probably go to where we were earlier. Y equals. And then I can plug this stuff in. So go to Y equals. Plug in there. Negative 2.54, right? Yeah. X. Don't forget your X. There's your X right there. There's X right there. Right there is your X. Negative 2.54 X plus 89.83. So don't forget your little X, dude. And then if you hit graph, that's the line of best fit. So it's got an equal number of points just about. That's not what's important. What's important is it's minimized the total distance to all the points to the line. And would you say this is a good fit? Is that a good fit? Oh, hell no. What's the more objective measure is the R. R is really close to 0. Remember, it was negative 0.33? You guys remember that? You just saw that a minute ago. R was negative 0.33. Really close to 0, and 0 would mean no correlation. I like it. All right. You guys go ahead and try to do the other set of data. You guys see that?
You know how I got an error every time when you give breakfast to the question of this thing? Every time I have to do those.
Every time you put new data in, you would hit zoom 9, zoom stat. Yeah. The thing with your window range, the window is set wrong. But when you did zoom stat, it resets the window anyway. So that's why that error went away. Negative 0.3 per second. There's
The first one is
so again.
that's the first one.
Oh yeah, just leave it.
Is it
Yeah, yeah.